Foggy type 1.
Type 1 ही है. Type 1 ही है. Type 1 ही है.
So Z में है.
Type 1. So if it is type 1, what would be the projection of it? So what should be the projection of this actually? So it's going to be a disk actually. So the S must be, S is a disk. Okay. And what is, okay, do we have a restriction over the disk? Okay, so S is a disk. There is no restriction over the disk actually. Okay, so S is disk. I'm gonna soon write it more precisely. Okay, so it's a disk actually. So this shadow is going to be some disk. All right. So this disk is going to have a radius? Yes, it is going to have a radius. So what would be the radius of this disk actually? So it's going to be h नहीं होगा. H तो height है.
होगा तो ये पैराबोला का फंक्शन है.
So it's going to be z square plus h square. So what would be the value of z at this top actually? So it's going to be z equal to h. So if it is z equal to h, so this is representing x square plus y square equal to h. So what is the radius of it? So square root of h. So the s is really, s is really this x square plus y square equal to. So it's a collection of the points x, y such that x square plus y square equal to x. So that's really what s is. Okay. This is what that we have to. So in other words, when you are solving a problem, you have to figure out these basic ingredients actually. Okay. All right. What are the boundaries of it? What are the boundary of this Fubini type region? So the one is this disk. Okay, and the other is this top actually. Okay. So the phi 1 of xy is really, the boundary functions are, okay. So one is this Pauli path actually, curvy path, and other is just top. So that would represent the surfaces actually. So phi 1 of x is this one, x square plus y square, and the other, phi 2 of xy is going to be equal to the h, the top one actually. So z equal to h is the top one. ये जो है ऐसा समझ लें, इसका top है और the bottom is this curvy point actually, okay? Which you can always write it as x square plus y square. Why I can write it as x square plus y square? Think about it, because you can treat this as a stack of the circles actually on each other actually, okay, whose radiuses are increasing gradually. Okay. So x square plus y square equated with some constants, for example, is going to give you the level curves of it actually. Okay, so this should be the case. So what should be the next thing? The next thing should be that, okay.
So लेकिन वो जो डिस्क होगी इसके ऊपर वो भी तो है, मतलब h को वो h होगी और h भी तो एक x square plus y square सर्किल की इक्वेशन ही है.
नहीं, so I'm not taking the entire plane actually. Okay. So I'm taking only that part of the plane that is, taking its input from this S actually. So it would be a disk, this top disk actually. So मैं पूरा z equal to h नहीं ले रहा, okay, वो points ले रहा हूँ कि जो मैं इस S में से लूँगा, okay. And if I'll take all those points, for example, from which are from S, and you assign a value h to it, so you're going to get automatically this disk actually as a result. Okay. So what would be the next thing? The next thing would be the density. So the other comment, that density of the gas at a point x, y, z is equal to that how much this point is away from the x-axis. So this xyz can be an arbitrary point inside the, what do you call, this bowl actually, okay? Because the gas in the bowl is everywhere, okay? So you are taking an arbitrary point in the bowl, okay, xyz, and you want to know the density of it. And it is told, it has been told us that this density is proportional to the distance of that point from the z-axis. So if I take an arbitrary point here, okay, so what would be its distance from z-axis? क्या होगा? So think about it.
Circle x square plus y square over.
It's going to be x square plus y square. Can you see y is going to be x square plus y square? So consider, so take the cross section that contains the point.
Yes.
Just take the cross section that contains the point and look at it actually. So it's going to be a circle. So this point is somewhere here. Okay, and this is z-axis. And the coordinates of this points are x, y, and z. And the coordinates of this point are 0, 0, and z. ठीक है ना? इसके जो corresponding point है उसके coordinates क्या होंगे? 0, 0, and z actually. So what is the distance between these two?
Square root of x square plus y square.
So it's going to be square root of x square plus y square, and I can put a constant of proportionality. ठीक है? Now, what is density? What is the relationship between the density and the volume? Mass per unit volume is density. So in other words, if you want to compute, so here's a rough sketch. So if you want to compute the density, so you need mass per unit volume. Okay? And if you want to compute the mass, you need to know the density in the volume V. So what I'm going to do, let's take this small chunk of the volume and let's see that what is the density here. So it's going to give me the small chunk of the mass actually. So this is going to give me the small chunk of the mass. The small chunk of the mass in the small chunk of the volume is really this rho. Okay? So what are you going to do? If I'm going to write in this integral form, so I need to integrate. So if you want to find m, you need to integrate the both sides of this equation roughly, and it's going to be you need to integrate your rho, okay, of x, y, z in the dv, the small chunk of the volume. And what is dv? So it's really dx, dy, and dz over the v. That's what you need to do. Can we compute it?
Yes.
Yes, we can compute it. So you need to apply the Fubini theorem actually. ठीक है? So the Fubini theorem is going to be, so you can bring this k out. Okay? And you have this square root of x square plus y square. Let me get rid of this. And let's put, for example, dx, dy, and dz. Alright? So what is the limit on the x?
So, x is
0 to under root h.
Yes, sir. 0 to under
So
root
you can respect
h.
it. So let's do, for example, first with respect to z. Okay, this is good. If you know the z, so you have this dx and dy.
g का पता है x square plus y square. वो जो ऊपर लिखे जो दो कर्व्स थी 5
Okay,
और 5
so the first is this x square plus y
and
square,
h sir upper limit
and
h.
then you have this h. And then you need to integrate this rest of things over s. Okay? And I'm leaving this as a gift for you to solve further. It's a simple, so it doesn't remain anything complicated. Okay, कुछ नहीं रहता. So you can pull this out. There is no z here. You can pull this out. ऐसा ही है.
इंटीग्रेट करेंगे ना
And then integrate करेंगे तो we're going to get z minus square root of x square plus y square actually. And then the hint is to use the polar coordinates.
H
So see, this is typically engineering stuff. Alright. So I would like to end at having a little discussion. We're going to end as a little discussion over having the change of the variable formulas. So the next thing was this actually that we did in double integrals, that the change of the variable formula. So we're going to have the change in the variable formula in the volumes as well. So there was a diffeomorphism. There was taking the rectangles from the one region, okay, and throwing them in another region actually. Okay, so you are making substitutions because the integral is difficult, okay, so on and so forth. So you're going to have a diffeomorphism here, which is going to take one kind of volume. So it's going to take a small cube from one volume and is going to throw it into another kind of a volume onto a small cube actually. Okay, so we're going to do the substitution. So I don't know that how much time do we have, but so shall we do it? Okay, okay, let's just speak over spherical coordinates. Okay? So previously we did this. Okay, so we have little time, so I'd just like to quickly comment over spherical coordinates, because usually what happens, think about it. So you have to solve a volume integral or a double integral, then you use some kind of coordinates to turn it into something simple. Okay? So I would like to, so our first choice are that, most of the time, for example, if you are solving problems in electromagnetism or, different kind of, problems, you usually use these spherical and cylindrical polar coordinates, these works. Okay? What we're going to do in differential geometry, course, that you can create even your own coordinate system actually. Okay? And why you have all these coordinate systems? Okay? So which coordinate system is better than other? The answer is none actually is better than other. All are equal. Okay? So we are just used to of one kind of coordinate system x, y, z. So that's what. So we treat that as easy. Well, it's not something that there is something special about rectangular coordinates that we use them. It's easy actually. Why? Because we have Pythagorean theorem, so that helps a lot. In many situations, Pythagorean theorem helps you a lot. But in some situations, it doesn't affect. So you need to change the coordinate system actually. Okay? Anyway, so the spherical polar coordinate system. So what do you mean by spherical polar coordinate system? So imagine I am in this 3 dimension, okay, and I have a point actually. So I have 2 ways to reach this point, many ways to reach this point. In fact, so to reach this point, for example, one way could be that okay, you go along x-axis and along y-axis some units, and then along z-axis.
Cartesian coordinate system.
Okay, so Cartesian coordinate system. Okay, and then if this distance is x and y and z, then you're going to call this coordinate the coordinates. The address of this point is x, y, z. Okay, so it gives this coordinate really gives the unique identity to this point actually. Okay. The other way could be, one of the way could be that let's imagine this point. So I have the same point. Let's imagine I have this point, but this point is sitting on a sphere basically. Okay. So on a surface of a sphere. So let's draw an imaginary sphere. Okay. So like basically what I'm doing is here is that I'm drawing an imaginary cube. Okay. And I'm saying that this point is one of the corner in that cube actually. Okay. So I can draw an imaginary, for example, sphere. So this is really the imaginary sphere. And I'm saying that let's imagine that the point that I want to know sits on a sphere actually. and I'm sitting at the origin. Okay. Maybe let's assume that this sphere really has the center at the origin. Okay. So I have this imaginary sphere, and I'm sitting here. So what I need to do first? The first thing I need to do, I need to pull out the sphere actually. So I need to cover this distance. Okay. Then I can't have a rectangular motion on what you call sphere. So I need to kind of make an angular kind of a movement. I need to move kind of with some angle. So let's call this angle as the angle theta. Okay, and then so this angle is really the longitude actually. We call it the longitude in this manner. And then you need to move onto the sphere and reach to this point actually. And for that you need to make another angle. And this angle is what do you call phi? So let's call this phi. So I need to make these three motions, r, and then theta, and then phi. And here I need x and y and z. The question is, if through the both ways I'm reaching to the same points. The question is, are these both points, in other words, now the coordinates of this is going to be r, theta, and
phi.
For example, phi. Okay. The question is, are these points related with each other? Can we relate them? Okay. So can we relate them? So if I know the r, theta, phi, can I compute x, y, z? And if I know the x, y, z, can I compute r, theta, phi actually? So can I fetch out my x, y, z through r, theta, phi? The answer is yes. And how are you going to do it? Here's the thing. But as Sada said, you can just quickly finishing it. I'll read out this picture. And then you can assume it to be sitting on a, for example, point on a sphere. You're going to have a spherical coordinates. You can assume this point is sitting on a cylinder, so you're going to have the cylindrical coordinates. You can assume that this sphere is sitting on a, for example, this bowl, paraboloid actually, so you're going to have the paraboloid coordinates actually. You can have all kind of coordinates actually. Okay? And none of them is really different from other actually. So everyone has advantages. So here's the thing, x, y, z, and I want to reach to this point. Okay? So I'm moving this way, and I'm moving this way, okay, and then moving this way. Okay? Moving this way. While if I want to incorporate these angles theta and phi, so there is angle theta, so the angle theta is this actually. Okay, and where is my angle phi? The angle phi is this actually. Is it making sense? So this is really the angle phi that you need to make. So how much you need to go up? Okay, so this is really the angle phi. Are you getting the point?
Yes.
Okay. And now I would like to determine, and what is r? So r is really the distance of this point from the origin actually. Okay, distance of this point from the origin. So can I write x, y, z in the terms of r, theta, and phi? The answer is yes. So from where should I start? So let's start from this triangle, and let me redraw this triangle here actually. Okay. Let me give these names. So let me call this line as line 1, and this line as line 2, and this line as line 3 actually. Okay? So let's just make sure of it. So where is this 1 here? So this is 1, and this is 2, and this is really 3 actually. Okay? So the angle is being made between 1 and 3. So this is the angle, what do you call phi. Okay? Question is, what is this length? Can you figure out this length?
Z.
Yes, we have, but then how much is this in the using this triangle actually? So this is y-axis actually. So how you can write y in the terms of an angle and this distance r actually? So it's going to be r sine phi actually. So this is going to be the r sine phi. Is it making sense? I will talk in a moment about this guy. So what would be this actually? So this is r cos phi actually. Okay. And now let me think about this triangle that is sitting in this manner actually. Okay, so let's make this triangle. So let's call this as one side. This is really the second side, and this is really the third side actually. Okay. So what is 1? So the 1 is this, and the theta is this, 3 is this, and 2 is this actually. Okay. So this angle is really the 90-degree angle.
Yes.
Okay. This angle is really the 90-degree angle. Okay. Question. What would be this?
This r cos theta.
Again r cos theta. It's base.
So it is base here, but
X, Y.
can you think about this 3? Because if you first figure out the 3, then it's easy actually. But this 3 is common between
R cos phi.
So this is really the r cos phi actually.
Yes, sir.
Okay, this is r cos phi. So now, what would be this? Sine. So the perpendicular over
R sine.
So it's going to be sine theta is going to be perpendicular over hypotenuse. So what is perpendicular? The perpendicular is this side over hypotenuse is this r cos phi actually. So this guy is r sine theta cos phi. Is it making sense? Okay. And how about this guy? How about this guy?
सर इनके स्क्वायर करेंगे तो नीचे वाला बेस मिलेगा.
स्क्वायर क्यों करें? ऐसे ही बताओ ना. So it's gonna be, you're gonna say the base is really, so this base is really, okay, so the cos theta is base over hypotenuse, so the base is really, hypotenuse is r cos phi cos theta. So this is r cos phi cos theta. R cos phi and cos theta. Is it making? You got this?
Yes.
So what are the primary distances that I'm interested in? I'm interested in this distance and this distance and this distance actually, because I want to write them in the terms of r cos theta phi. So I know about this guy. So this is a distance along y-axis. So my y is what?
R sin theta cos theta.
आपकी बात है?
Yes, sir.
तो r cos theta cos phi.
ये होगा ना, ये r sin theta cos phi तो ये है ना?
This is r cos
नहीं, नहीं,
theta.
नहीं.
So R sin theta cos phi होगा ना?
It's going to be r sin theta
Cos phi.
cos phi. So that's my y. So what is x?
R
और
cos
इसकी
theta.
base है r
R cos theta
cos theta.
cos phi.
You know really the cos phi. And what would be z?
R sin phi.
It's going to be r sin phi.
Yes.
Okay? And if you remember, this was indeed, I mean, think about it. So what was my PUV for the sphere?
Yes.
So this has this weird description actually in the terms of the U and the V actually. So isn't that this actually?
Yes.
Think
Yes,
about
sir.
it. Okay? So it makes sense. So it has this weird definition and we have no idea how it came into existence. But now I know that, okay, if I treat this as a point on the sphere, I can write this point in the terms of the parameter. And if I assume that this distance is fixed, I can write the coordinates of this point lying on a sphere in the terms of theta and phi, which was previously in the terms of the u and what do you call v. So you have really the parametric representation of it actually. Okay, and what बाकी भी आप कर सकते हैं इसी तरीके से. For example, okay, so how if you want to find theta cos phi in the terms of others, वो कैसे r कैसे compute करेंगे in the terms of x y z. So if you want to go other way around that,
Yes, sir.
so square these three. So you're going to get x square plus y square plus z square is r square. So r is the square root of x square plus y square. How are you going to find, for example, theta? Take the ratio of it actually. Okay. So y over x.
cos
So this is going to get rid of the cos phi and r and r. So you're going to get the theta as the tan inverse of
x upon
y over x. And how are you going to find the phi? From here. So z over r is tan inverse phi.
standard 0.
So it makes sense. Is it making sense?
Yes.
See you in the next one.